A ball is thrown upward with an initial velocity v0 from the surface of the earth. The motion of the ball is affected by a drag force equal to m gamma v squared, where m is mass of the ball, v is its instantaneous velocity, and gamma is a constant. Time taken by the ball to reach to its zenith is, zenith means the peak point, 1 upon root of 2 gamma g tan inverse of root 2 gamma by g v naught, 1 upon root gamma g tan inverse of root gamma by g v naught, 1 upon root gamma g sine inverse of under root gamma by g v naught, and 1 upon under root gamma g ln bracket 1 plus root of gamma by g v naught. Okay, so it is clearly a kinematics problem, although they say drag force and all. Okay, the ball is thrown upwards. Okay, now you tell me, what convention do you want? Do you want vertically upward positive or vertically downward positive? Upward positive. Okay, upward positive. Okay, now because we want time taken by the ball to rise to its zenith, we know that at the zenith the ball's velocity is going to be 0. Correct? So what equation are we going to start with? We're going to start with A equal to dv by dt. Okay, because we are now dealing with instantaneous velocities. Okay, so A equals dv by dt. Is it possible to tell me, okay, can you guys tell me the expression for acceleration here? There are two things, negative g, gravity, and now see, because the motion is positive, drag will be negative. Well, if the motion is in the upward direction, the drag will be in the downward direction. Okay, so negative, we only want the acceleration, so we have to ignore the mass, so it will be gamma v square. Gamma v square. Do you understand this? Just an observation. Just an observation, not relevant, not well related to the problem, but if ball were moving downwards, we would have taken A as negative g plus gamma v square. Do you get it now? Drag force is like friction opposing the motion. Okay? Acha, let's now resume with our velocity. Okay, so what I'll do is I'll separate the variables. So dv by, it is I'm going to keep the negative sign here. It is g plus gamma v squared. Let me write it as v squared plus g by gamma into gamma. Have you followed this? Okay, I've done multiple things here. First, I've reversed the order and then I've taken gamma common. Fine. And if you want it to be in a more familiar form, let me write it as root g by gamma square. Okay, root g by gamma square equal to negative dt. Now comes the time of, okay, limits. When t was 0, the ball was moving with velocity v0. We want to find time, let us call it capital T now, when the ball reaches its zenith. That means this will be 0. Okay, this will be 0. Now let us use the property of definite integration to flip the limits. Okay, because this sign is negative, the integral is negative t. So if I want to find t, it's going to be the integral from 0 to v0 dv by gamma bracket v squared plus under root g by gamma squared. Okay. Now what is the formula that we can use here? The formula is integral of 1 upon x squared plus a squared with respect to x is 1 upon a tan inverse of x upon a plus c. Now definitely c and d are gone now because they are sine inverse. So whether it has this 2 here or not, that is the question. Okay. Now integrate this. 1 upon gamma as it is 1 upon a, so 1 upon root of this. Okay, so it is going to be root gamma by g, right? And well, I'm sure there is no chance that we'll have 2 here, so the option is B, but we'll work on it. Okay, and in the competitive exam you may stop right there, no need to continue because you have got the option, right? You have got option B. Tan inverse of, what will it be now? Root gamma by g v naught, because tan inverse of 0 is 0. Okay, because tan inverse of 0 is 0. Okay, so root, and in the denominator it will be 1 upon root gamma g tan inverse of root gamma by g v. Okay, so that is option B. That is option B. Understood?